Hamel Engineering, your sustainable power solution. Solar photovoltaic system. In this video, we will discuss about solar photovoltaic or PV system. During this lesson time we will learning about PV technology, PV types, PV system components and PV module rating. Before going to discuss about solar PV system, let's talk about the two form of energy deliver from sun. Sun delivers its energy in two main forms. The first one is solar energy to thermal energy and the other one is solar energy to electricity. Let's start from solar energy to thermal energy. Solar thermal systems operate when radiation/heat from the sun is directed to a device which captures and concentrates the heat to a carrying media, air or water. The fluid gains heat from the pipe/fins installed within the system and delivers it through an outlet either as warm or hot. But solar energy to electricity means electricity from the sun. Photovoltaic technology is used to convert light energy into electrical energy. This technology has been developed on the basis that some semiconductor materials such as silicon generate voltage and current when exposed to light. A typical silicon solar cell produces only about 0.5 volt, so multiple cells are connected in series to form larger units called PV modules. PV string individual modules can be connected in series, parallel, or both to increase either output voltage or current. This also increases the output power. When number of modules is connected in series, it is called a PV string. In series connection, the negative terminal of one module is connected to the positive terminal of the next module. In series connections, voltage adds up and the current remain constant. PV array. Multiple PV strings are connected in parallel to form a solar array. Parallel connection increases the current, while voltage remains the same. Solar PV type. Basically there are three types of solar PV type. They are monocrystalline silicon PV cell, polycrystalline silicon PV cell, and the third one is thin film PV solar panel. Now we discuss each one of them in detail. Let me start from monocrystalline silicon PV cell. Monocrystalline cell comes from a single crystal ingot of high purity, with typical dimensions of 12.5 or 15 centimeters. The ingot has a cylindrical shape, which is cut into thin slices and made round, semi-round or square shapes. Polycrystalline silicon PV cell. Polycrystalline silicon cells are formed by casting in a cuboid form ingot. The ingot is cut into bars and sliced into thin wafers, a thin sheet of semiconductor material, which in turn are used to create the cells. These cells are less efficient than monocrystalline. Thin film PV. Thin film photovoltaics are produced by printing or spraying a thin semiconductor layer of PV material onto a glass, metal or plastic foil substrate. By applying these materials in thin layers, the overall thickness of each photovoltaic cell is substantially smaller than an equivalent cut crystalline cell, hence the name thin film. Solar PV system components. There are so many components used in a solar PV energy generation system. The most common are 1. PV solar panel, 2. Inverter, 3. Controller or solar regulator, 4. Storage battery. Let me describe each and individual. PV solar panel. The solar panel produces electricity when there is sunlight by converting it into DC. Photovoltaics, PV, or solar cells are the building blocks of solar panels. They are made of semiconductor materials and convert sunlight into direct current or DC electricity. Solar panels are usually arranged in groups called arrays. Array is made up of PV modules, which are environmentally sealed collections of PV cells, the devices that convert sunlight to electricity. Solar controller? The solar charge controller is basically a voltage and current regulator which is connected between the solar panel and the battery and load. Its main function is to manage the charge and discharge of the battery and keep the battery pack in good condition. The charge controller regulates the voltage and current flowing from the solar panels to the battery. Since most solar panels can produce more than the rated voltage, without the solar controller the battery will be damaged due to overcharging. This is so because maximum voltage for most batteries is between 14 and 15 volts. The figure below shows a typical solar charge controller. However, they come in various forms and designs depending on the application and manufacturer. They vary in terms of their working voltage or system voltage and the current that they are supposed to handle during operation. What is inverter? The photovoltaic array and battery produce DC current and voltage. The purpose of an inverter is to convert the direct current, DC, to alternating current, AC, used by your electrical appliances and exportable to the AC grid. The inverter may be built as standalone equipment for applications such as solar power, or to work as a backup power supply from batteries which are charged separately. Storage battery. The primary functions of a storage battery in a PV system are 1. Energy storage capacity and autonomy, to store electrical energy when it is produced by the PV array and to supply energy to electrical loads as needed by the system or on demand. 2. Voltage and current stabilization, to supply power to electrical loads at stable voltages and currents, by suppressing or smoothing out transients that may occur in PV systems. 3. Supply surge currents, to supply surge or high peak operating currents to electrical loads or appliances. Solar panel mounting structures. Solar panels perform best when exposed to direct sunlight. For that to happen, modules get mounted at an angle facing the south. This is where solar panel mounting structures come into play. Solar mounting structures are critical components that ensure the efficiency of a solar power system in both utility and rooftop applications. These frameworks allow panels to rest comfortably at the right angle, which helps in maximizing energy generation. Solar panel clips. Used to attach hardware cloth to the base of solar panels without drilling through the panel bases. DC cables. DC cable used to connect the photovoltaic panels to the inverter and battery bank. They are designed to handle high voltage and high current levels, making them ideal for use in solar energy systems. MC4 connectors. Single contact electrical connectors commonly used for connecting solar panels. The MC in MC4 stands for the manufacturer multi-contact and the 4 for the 4 mm diameter contact pin. PV module rating. In the solar industry, the peak power rating of a panel is frequently abbreviated as kWp. kWp is the peak power of a PV module or system that describes the energy output of a system achieved under full solar radiation under set standard test conditions, STC. Solar radiation of 1000 watt per meter square, module temperature of 25 degrees Celsius and solar spectrum air mass of 1.5 is used to define standard conditions. This is generally referred to as a full sun condition, that is full irradiance. Less than full sun will reduce the current output of the cell by a proportional amount. For example, if only 1/2 of the sun's energy, 500 watt per meter square, is available, the amount of output current is roughly cut in half because the solar cell only has half the brightness to generate electricity. Reading a solar panel nameplate. Maximum power means it can deliver maximum 375 watts electricity. Maximum voltage means its maximum output voltage is 34.5 V. Open circuit voltage means the voltage without load. Maximum current means the maximum output current. Short circuit current means the current of short circuit of solar panel. Maximum system voltage means that, when we connect solar panel in series, then maximum voltage limit is 1500 V. Solar power system wiring connection. Broadly, there are 5 steps for wiring the solar power system. Step 1. Connect the battery. Before connecting the battery, check the open circuit voltage of the system. Battery.it must be at least equal to the controller operating voltage. The battery should be connected first. This will activate the controller self-protection features, and will power the LEDs to guide installation and startup. Step 2. Connect the load. Turn the load off. Connect the load to load terminal, and then turn the load on. Step 3. Connect the PV array. The rated voltage of the solar controller should be lower than the input voltage of the solar panel. Step 4. Check the connection and Step 5. Check the power. In the next video, we will show detailed connection of solar energy system one by one. Please make like and subscribe for more video. Thanks for watching.